Okay, I have to use a microphone today because of this tool here. And we have some remote guests probably out somewhere in the UK and maybe Germany and France and wherever. So greetings from Helsinki and welcome to our lecture of this afternoon. I have the pleasure to briefly introduce Henry Weber here on my side, but before talking about you, I would like to thank Nicola and the students and also for coming today to this lecture. Thank you very much for helping us to basically co-organize this event. Now Henry is from the University of Bristol and he has the pleasure to be my last PhD student from my Bristol time.
Yeah, I'm still hanging on.
And not only that, but Henry is about to stand the defense of his PhD, the so-called Viva in the UK, actually next week. And that's why we thought it's maybe a good opportunity also for him to practice a little bit about how to defend his PhD by giving a lecture here with us. And I'm inviting you all, of course, then to ask very nasty questions at the end of it, so that we can really have a good try on showing how well he understands the topic of his PhD. Well, Henry was a student from actually undergraduate times with us in Bristol. We bumped first into each other when you were already doing your MA, I reckon.
Mm-hmm, yeah.
And then he was accompanying me to a field trip in Hungary, where we dug Jan in Hungary in, I think it was some 5, 6, 7 years ago.
5 or 6 years ago, yeah.
And from that time, we stayed in contact. I took over the supervision of PhD along with 3 other colleagues, Mark Horton, Martin Bell, and what was her name?
Wendy and Amanda. Yeah.
Exactly, Wendy from Reading. And he had also the pleasure to have a co-supervision between Bristol and the University of Reading, because also of the complexity of the topic of his PhD. And this is exactly what he's going to talk about today, about archaeology and precision farming agriculture, basically Agri-Tech, as he is called it here, or he is calling it here in the paper for today. So Henry, thanks for coming over.
Thank you for inviting me as well. Yeah.
And I hand over this nasty microphone.
Do I need? That's all. Said. Brilliant. Well, thank you all for coming. Yeah, it's going to be a fairly quick story of my PhD and the research that is sort of centred around archaeology. Trying to think of a snazzy title, I came up with Understanding the Past for a More Sustainable Future, and hopefully by the end we'll be convinced it's beneficial, relevant to sort of ideas. So the first thing I thought I'd go through is a bit about why agriculture and why archaeology, how the two mix, because traditionally I guess there's an awful lot of archaeologists that work on agriculture, but they're more to do with studying past agricultural societies, past ways of practicing agriculture, and not necessarily so much around modern agricultural practices, and actually merging archaeological methods with agricultural methods in terms of studying soils and studying crop marks and sort of those sorts of things. So I'm a bit of a hybrid between the two, and that's how I came up with the thinking. I'm a farmer's son. I've grown up in Essex, just north of London, and helped run the farm all of my life part-time. But at the same time, also graduate, I, as part of my undergraduate dissertation, actually, the image on the right-hand side there is a medieval gatehouse that is on the farm that I excavated for my undergraduate dissertation. So I've been interested for a long time about how archaeology and agriculture mix together, and that was sort of what formed really my ideas for some research, which started off as a master's, an MPhil, I did at Bristol, really focusing around geophysical surveys. So I've always been quite into more of the geophysical surveying aspects of archaeology. Done quite a lot of different sites using different methods, and this was one of the first things that I thought, well, let's have a think about how geophysics cuts across both archaeology and agriculture. because I became aware that this thing of Agri-Tech, this sort of precision farming, the use of technology within agriculture, was driving farmers to pay people. On the right-hand side, there's a guy on a quad bike who's surveying a whole farm using a conductivity scanner. And this, I was sort of comparing how archaeologists were doing geophysics. And it tends to be that archaeological geophysics is smaller scale. We focus on smaller areas. We probably have less sort of resources and time and money to put into these sorts of things. But we do it at a higher resolution, do it much more detail than agricultural surveys would sort of do it. And we tend to use quite a lot of different geophysical methods to study the soils and to find archaeological sites, whereas in the agricultural world, there's a single method. They tend to only use conductivity surveys just because they're mapping soils at quite a large scale. They don't need to do so much. This is the first sort of set of thinking between the two. And as my ideas developed, I tried to then turn this into more of a PhD project. It was a bit wider, thinking about different perspectives of, again, merging the methods that archaeologists use to find sites, the methods archaeologists use to sort of manage heritage and manage sites, as well as the way farmers are doing similar sorts of things. So there's on the top left there, satellite imagery starting to be used a lot in the last sort of decade to 15 years. The tractor-mounted sensors that are now sensing the crop as tractors drive over the fields. Archaeologists are obviously doing much larger scale geophysical surveys now with multi-method approaches, maybe doing magnetometry, GPR, conductivity, all sorts of different types. And so I was trying to think about how I could link that all together. And that really is sort of the But there was one thing that was stopping a lot of this research happening before, I think, in that there are lots of stereotypes, and I don't know whether this applies to Finland or other countries, but certainly in the UK, people have certain perspectives over who archaeologists are and what they look like and what they do. And a lot of people, there's a programme called Time Team in the UK, I don't know how many of you have seen Time Team, but it was very famous, and it sort of made archaeology very popular and gave it a very good sort of public image. But archaeologists became known as people who dig very sort of small holes in the ground and generally a bit grubby and dirty and sort of, you know, rather than people who are perhaps doing very large high-tech surveys across landscapes to try and understand past societies. Farmers didn't necessarily understand archaeologists as that. And equally, archaeologists probably have perspectives of farmers as people who just sit in big tractors. This is a magazine called The Farmers Weekly, which gets all of your topical farming news to farmers in the UK. And people think, oh, farmers don't care about archaeology, they plough their fields, they, you know, cause damage to archaeology. And these sorts of stereotypes, which I could see because I was sort of part one and part of the other, just meant that there wasn't really an awareness of the linkages between the two and whether people could actually share data between the two sort of communities. And again, sharing ideas of what they're doing in looking for archaeology or mapping soils and where the sort of crossovers were. So I'm going to go through a few larger agricultural challenges to sort of set the scene for again, why my research has been quite timely, I guess. And one of the biggest things is global population increases. There's all the figures about projections of what the population will be by 2050. And obviously agriculture sees the need to, you know, produce more food, produce better quality food, and also make food, I guess, more available and accessible. And therefore, they've got to do this, but they've got to do this in an environmentally sustainable way because, of course, agricultural intensification and modern farming techniques have not really been sustainable over the last 100 or 200 years because of, you know, degradation of soils, land management, meaning that there's quite a lot of biodiversity loss. All those sorts of issues are becoming really quite relevant now, and agricultural sort of communities are looking to find ways to make their methods better and use technology perhaps to sort of increase their productivity but sort of reduce their sustainability or reduce their impact on the environment. Of course, that global population increase is not necessarily all going to be in the same geographical parts of the world. So this slide here just shows that there's two sorts of different types of soils really in the world. You've got sort of very old soils, and generally in sort of African and Asian continents you generally have quite old soils like the ones on the right, which have actually had quite a degree of weathering and leaching. They don't actually have very many nutrients and minerals locked up in them because they are so old. Whereas the more recent soils in sort of temperate areas and sort of northern Europe and things like that have still got a lot of minerals in there. And this means that actually in the global population increases that may be happening in society, these are happening in places where the soils aren't that capable of producing more food because you need more nutrients. So that just intensifies this problem of how to sort of produce more from less. And this is just a sort of continuation of that story, but in fertiliser prices. So fertilisers are obviously key inputs to the soil to get crops and produce crops with higher yields or produce crops with better nutrient containment sort of thing, so that you've actually got the right nutrients in those crops. But of course fertiliser prices have been going up. They depend on the global economy, and so there's a spike in 2008 where there was a massive price rise of fertilisers. And we've got to think about this not just from a nice developed country perspective where you can afford fertilisers, but in parts of the world where you can't afford fertilisers. And we've got to think about ways of recycling nutrients, because plants need nutrients, and if we can't get fertilisers, where do we get the nutrients from? And there's even more challenges, because it's not just fertilisers that are problematic for farmers to sort of having to deal with. It's also, over the last 100 years, farmers have increased yields quite a lot, mainly because of nitrogen and phosphorus fertilisers. But we're seeing plateauing yields now. There's been sort of a damage off over the last decade of yields where we just can't increase the yield. Partly because some of these other issues about pesticide resistance, herbicide resistance, again, it's coming back to those ideas that current agricultural methods aren't really working. They're not sustainable. They're increasing resistance to pesticides, which then means pests are becoming more problematic. It increases the need to then sort of genetically modify crops to become resistant to things. There's a whole, I guess, the nutrient deficiency from a health perspective as well. Again, trying to make sure that people have the right sort of healthy diet with the right mix of nutrients, both macro and micro. And climate change, of course, involved in all of that, really. Extreme weather, flooding, droughts. All of this makes it harder for farmers to produce crops and to do it in a more sustainable way. And that's sort of the point, that everything's sort of constraining on becoming more productive, but with a more sustainable sort of set of methods. And this is just one image from a recent Agri-Tech conference where they're trying to pull together all the different ideas, different approaches to try and come up with better solutions for agriculture, and trying to pull together ideas around society, soils, crops, humans, animals and environment, and see if there are potential solutions. And Agri-Tech, so agricultural technology, is really one of the sort of forerunners, I guess, for how to solve some of those problems. And it's almost inevitable that technology will be used in some way to sort of increase this productivity. We've got things like sensors, high-tech sensors to help detect when to harvest crops at the most appropriate time. Again, looking at cattle, now people are starting to tag cattle with GPS trackers so they know not only where they're going, but they've also got temperature sensors on them so they can tell when they're ill, so that then you can target when you need to give them medicine. One of the big things, of course, is like antibiotic resistance. We shouldn't be just giving antibiotics to lots of people. We should be doing it a lot more targeted in a precise manner. But that can only be done if you know about when to do it and where you need to do it. And the same thing applies to crops. So again, technology within crop farming. robotics is one of the biggest things that we're sort of seeing being developed, especially in the UK, but I think all over. People are becoming more expensive, I guess, to pay and to work. So robots are now things that can actually be running all the time, day and night, but could do it on a much more sustainable way. They don't damage the soil as much. They're not as big and heavy. They don't have to spray the whole field. We can have swarms of drones that can go and spray individual spots in fields. And then the other picture of it is, again, sort of traceability and food angle to it. With more technology monitoring all of this sort of food chain element and food production, it means that people can understand more about where their food comes from, what it's got in it, how good it is to them, and how well it's been produced. Again, tying back into that sustainability angle. So that's just a bit of a background, really, to the whole Agri-Tech scene. And what I want to do now is go a bit more into what my research is really focusing on, and it's sort of centred around this idea of precision farming, which is more about targeting inputs into fields. It's about taking one field, and instead of managing that whole field in one way, you can divide it up into zones and manage it more precisely. So again, you're not spreading the same amount of fertiliser across the whole field. You're targeting it to, depending on what nutrients are in your soil already in these different zones. And there's a whole cycle, a whole life cycle, I guess, of data, essentially, that goes in this process. Because again, if you can't make those decisions if you haven't got the information and the understanding of variation within the landscape and within these fields to actually make those decisions. So this is just one field, and this is basically a year's worth of data. Farmers now will take their field, they'll collect some satellite imagery about it, they'll collect some other sort of different spectral imagery to tell them about their soil types, then they'll zone it into different zones, they'll test those different zones in fields for what nutrients they have, then they'll plant their crop, and then the last three images there are satellite images, again looking at how healthy that crop is throughout the season. So it measures something called NDVI, which is a vegetation index to see how green basically the land is. And then you can also record the yield. So at the end of the year, the farmer harvests his crop. He can then look at the yield, and the whole thing over years, you just get a cycle coming in with more and more information to drive more and more decisions, essentially. So that's the precision farming sort of circle. But of course, it's not only the agricultural challenges that are sort of being faced at the moment. Archaeological heritage, especially in the UK, we've recognised that agriculture has been one of the most damaging sort of impacts on sort of archaeological remains, I suppose. Since 1870, we've got evidence of comments being made about how intensifying agriculture and ploughing up grassland is actually one of the most damaging things you could do. In England, 84% of our scheduled monuments, which are most sort of nationally important monuments, all lie on agricultural land. Of course, it's a large land mass, it's well utilised in England especially. And even though we recognised it such a long time ago, there's still the same problems. In 2015, 40% are still under arable cultivation. The image there is where a prehistoric enclosure, but with ridge and furrow, medieval ridge and furrow on the top, and of course you can see the sort of effect that ploughing has had, and this is not sustainable either, not just from an environmental perspective, but also from a heritage perspective, trying to protect and also record our sort of cultural heritage. And the other angle to this is not just about managing our heritage, but also about this finding out and prospecting for archaeology, trying to find new archaeological sites. Again, we're seeing the influx of technology into that. The same stories about trying to use drones to then use maybe have LiDAR scanners on drones to try and find the most detailed sort of variations in soils. The image is a great image there of a whole load of archaeological sites and remains in that field. And it's really trying to find those, record those in as many different ways as possible, because not only one method doesn't work in every scenario. We're starting to realise that we need to use multi types of techniques at multiple times and are surveying a larger area to really understand landscapes and not just archaeological sites on their own. So trying to join those two together, my research questions for the PhD were really to take areas of land at 3 case study sites, and I mainly concentrated on one field at each site, to compare and contrast all of this agricultural data and all of this archaeological data. And my main focus was really to sort of gather what was already there. I couldn't collect all of this new data, but actually it was a really good test to see what data was already there and could be collated and pulled together. So that was one of the key things I wanted to do. But then also to understand how archaeological sites impact soils, but in an agriculturally relevant way. In terms of geoarchaeology and wider sort of archaeological science, impact the soils in this specific context. But what I'm trying to do is then put that back into the landscape, if you see what I mean, and see how that changes farmers' perspectives about what they're doing and how they're managing their land. And then, of course, trying to really promote a bit of mutual dialogue between archaeology and agriculture, between farmers and farming companies and archaeologists and archaeological companies. Again, trying to get away from that stereotype idea and actually saying, well, look, guys, you're collecting drone data. We're doing it in the same areas and the same scales, maybe even looking at the same things. Why aren't we maybe sharing a bit more information, a bit more understanding? Can archaeology help understand precision farming data, that sort of thing? So this is just a bit on the methodology, just showing the sort of range of different types of data, different sort of pieces of information that I was looking at. Again, sort of collating these all into GIS, taking the historical modern maps, yield data, soil analysis, geophysical data, really trying to join together a huge number of data sets. I think I had about 34 different data sets on each site, with obviously very different backgrounds in each one, which is quite a challenge, I think, for the PhD, really. But then, of course, when I got all of this data, I had to have some sort of comparative data set to actually understand it. So I also did some soil sampling to look at the geochemistry of the topsoil and the subsoil, and doing some cores to understand the stratigraphy of soils in the field, to again really see, do archaeological sites complicate soils further? Farmers think they understand their soil because they drive over it every day, which is have actually in the past, and that could be 20 years ago. So yeah, there's some of my main real methodologies. So I'll just go through, I won't go through a site-by-site results, because I think that'd be a little bit boring. I'm going to try and go through it in a sort of more of a result-based way to see what I've found really from looking at all this, comparing all this data together. But that's the location of the 3 case study sites and each of the fields there. So one of the biggest things that I've recognised across all 3 case study sites was that precision farming collects this data. I showed you some images before of these satellite images. You've got these sort of good areas of crop and poor areas of crop, but you don't really understand why that area is different. All that satellite image is telling you is that it's a greener, healthier crop. On this case study site, we had some previous geophysics from an archaeological survey done by a university. And there's an Iron Age enclosure with a nice little ditched enclosure with a number of little pits inside it, and a few antennae as well. And that is exactly where it was. So we were seeing the direct impact of archaeological features being shown up in precision farming data. But the problem was precision farming specialists who were selling this data didn't know what was causing it. And so they didn't really know how to understand that or how to vary whatever they were trying to vary for the farmer, whether that's fertilisers, whether that's seeds, which was just problematic. I think that actually there's quite a lot of scenarios from my experience of some of the precision farming world where they don't really bother trying to explain things. They just sort of say, oh, it's there, it's a blob of some sort, don't worry about it. But actually by understanding that, we can take it a bit further and say, well, why is that archaeological site the crop growth in that way? And here's a little image from the site in the winter of, I think it was 2015, and I don't know if you can just make out, but you can see the crop growth in these areas really sort of quite different from the other areas around it, and that's because that's in one of those pits. And this is in the winter, where traditionally, from an archaeological survey point of view, you wouldn't really do much surveying in the winter for crop marks because you tend to see them in the summer when you're having drought periods. So this shows one thing, that you can also see some of these crop marks really quite early on in the growth of a crop, and how it affects the plant itself. The right-hand plant there is taken from inside the pit, and it's got a much longer taproot, much healthier, larger canopy, and that plant will probably yield quite differently to the other plants in the areas, because of course there's lots of organic matter in these pits, depending on what's been put into them. And so another step was part of the, again, I said I did lots of sampling and lots of coring. So here's a core transect across that field, and the average sort of soil depths there are all about 30, 40, 50 centimetres. And of course these three very deep soil cores, until you reach the sort of natural chalk geology below, we're all over a metre, metre and a half, 2 metres in some cases, and all relate to archaeological pits or ditches within that field. So again, it has a completely different, precision farming people are trying to take the precise approach in managing those plants, but if they don't recognise that the variability is far more complicated than they thought, then they could be making the wrong sorts of decisions. This is the same core, which is just one core, the one in the middle of the pit, and I did some XRF analysis on those soil samples to have a look at the geochemical variation in the soils. And in the lower levels there, probably about sort of 1.2, 1.5 metres, we've got high levels of copper and phosphorus. Typical things I guess you'd expect, lots of elements that would be common with archaeological activity of various sorts. So I'm not interpreting exactly what that activity is. It's probably a rubbish pit of some sort, got a lot of organic matter, but crucially, those are all elements which plants take up, and roots will go down at least a metre to sort of scavenge for nutrients. So again, it just ties it into why those plants are growing much more strongly. So the next thing I was looking at was using our agricultural data to help perhaps find new archaeological sites on some of the case study fields. This particular field, on the right hand side there's a geophysical survey which is really high resolution. The University of Reading had their field school there 2 years running, so they've done a few excavation trenches on this field, as well as multiple aerial photographs from various times throughout history. So it's had quite a lot of work done on it, and it's generally assumed we know roughly what's going on in that field archaeologically. This is some hyperspectral imagery that I managed to collect through a company who again was sort of doing precision farming surveys. For those of you who don't know, hyperspectral imagery is where with a normal camera you're just taking the visible wavelengths of light and imaging that. With multispectral imagery, you would look at the red, green and blue values, those visible wavelengths, but you'd add in near infrared to help you look at plant growth, because it's a characteristic part of the electromagnetic spectrum for that angle. Hyperspectral is different again, where you take the whole spectrum almost and chop it up into lots of little bits. So you get a much greater range of values, which you can look at all sorts of things from diseases, stress to plant health, and you can look at elemental values of soils from these sort of things as well. So I was very fortunate to get this field flown just once in the sort of 3 years, I guess, I was monitoring the field. And what I saw little crop mark up the top, which I've outlined in the middle image there, which looks to me suspiciously like a long barrow. So in this field, the main central feature is a Neolithic henge. All of the boundaries going across it are Roman field boundaries, and there's a possible Roman farmstead there that was excavated. And up to the top left there was a barrow cemetery. And again, you can see a long barrow up on that side in another direction. This other feature looks suspiciously similar, but with no features in the geophysics, which is very strange. It could be because the soils are different, therefore the geophysics wasn't picking it up, but for some reason the hyperspectral imagery has picked it up. And it doesn't look like it's agricultural marks either. I mean, with parallel lines like that, you might see that it could be related to, tractor implements or something like that. But it sits off from the tram lines, it's got some curves at the end, and of course it's got the bit at the end that crosses off it. So I'm fairly confident that is something of an anomaly that, again, would be interesting to look at in more detail from an archaeological point of view. Another example in the same field, this time with a multispectral image from a drone. Again, that little outlined blue box. On the geophysics, all we can see is an L-shaped ditch. And because the soils change in the field, the sort of contrast of the geophysics changes, so then you can't see the rest of it. But in the multispectral image, it's a little bit faint, but you can see the edges just coming through of a square shape and feature. Which could be tied in with the Roman complex, but it could also be possibly some prehistoric remains as well. Again, until it's sort of dug, you wouldn't really know. But it's just highlighting these things that have been picked up through the agricultural data and that can help improve the archaeological sort of prospection of a site at the same time. So to turn that on its side is that sometimes agricultural data can help, but sometimes it couldn't help. So this is an example of the resolution difference between some of that agricultural data that I was talking about earlier. Normally with sort of drone-based or even archaeological data, you're trying to look at it at highest resolution to get the best interpretation out of it. And there's a 0.08, so an 8 centimetre resolution drone image, and then we've got exactly the same area but with a 5 metre resolution satellite image, which is sort of most common in some of the agricultural world. And you can't really see the henge, to be honest. It's not, there's bits of it that are showing there, but you wouldn't be able to interpret that on its own. So there's a lot of limitations with a lot of agricultural data as well. It only tends to be the higher resolution stuff that would really be in archaeological investigations. So moving on to another type of result really is how Agri-Tech methods and precision farming might be used to help conserve archaeology and protect it. As I said, cultivation was one of the major damaging sort of elements of agriculture that is done all over the country. Its impact is probably far greater than we really imagine anyway, just because of the extensiveness of it. So some of the new technologies coming through have allowed cultivators and ploughs to have auto depth control. So depending on the soil type you're in, you might not want to put your cultivator really deep because it'll be a very heavy soil. Therefore, you use more diesel in your tractor trying to cultivate it. So from a farming point of view, this is saving costs. And this tractor up here has a little electromagnetic device fixed to the front of it, and it's sensing the conductivity of the soil, and then it's automatically varying that cultivator's height depending on what it thinks it needs to do. And you can, of course, use pieces of software to then say, well, I'll draw a zone around that area because I know that I don't want to cultivate deeply around there. And it'll automatically do it. There's no human input at all. You just program it in, off you go. So, of course, the potential for archaeology is really quite great, because you could then program in these zones of archaeological areas where you know you've got a site, possibly even with a buffer zone, and that cultivator could just go up and down so that you don't go pulling your plough, your disc or tine through sensitive cultural layers essentially within the soil. And there's been some tests on this in Germany, but at the moment in the UK it depends on there's not that many farmers using this system yet because it's so new. and it's got to find its way. So although this could be amazing and really great, it's also got problems of only a few farmers, and some of the most high-tech farmers would be using this because they have to buy perhaps new machinery to do it. So there's also some limitations on that side. Moving on to fertilisers, as I said before, there's quite an important element of nutrient usage and trying to reduce fertiliser application, make it more efficient, make it more targeted. Fertilisers cause massive environmental pollution, really, from over-application of nitrogen and phosphorus getting into waters. So the other thing I really want to look at is the variation in nutrients in the field and how that relates to fertiliser application. So this is one site in Oxfordshire where essentially all the purple is archaeological interpretation. So you've got lots of field boundaries, you've got a Roman villa and sort of complex of buildings here, and you've got some other sort of quarrying and Iron Age activity there, and you've got some burials in the top there. Again, there's been some excavations on the field, there's been geophysics across the whole field to look at these features. And then the colours there represent the phosphorus variation in the field. So red is really high levels of phosphorus, and the blue and yellows are sort of the average areas. So roughly, that Roman villa has about double the amount of phosphorus in the soil because of human activity, human habitation, in comparison to the rest of the field. I was measuring, because with the X-ray method that I was using, it looks at the total amount of elements in the soil. It doesn't look at the forms of those elements, so whether those are in forms that plants can take up, which are usually in oxides. But this is a comparative map that the farmer had done years before, which does look at plant available phosphorus levels, and you're seeing a similar sort of pattern essentially arising. The same high areas are high still in the available stuff. So what we can see is that if we knew about this archaeological site, we can actually, if we knew, again, the phosphorus levels, which we do from this work, we can actually say that farmers could be reducing their fertiliser usage by perhaps nearly 0.4 tonnes per year, based on the recommended values for how much phosphorus you should add to your soil each year for, the crop to be within its normal ranges, I guess, of phosphorus. So that's a really interesting point, and again I was seeing variations across all three case study sites. Some, this one probably the most stark, some a lot more ephemeral, where of course you're dealing with archaeological sites where you don't know what activities have happened, what intensity, for how long. All those sorts of things mean that it's incredibly variable. But the point I'm trying to sort of make, especially to the precision farming and agri-tech world, is that archaeology definitely contributes to soil variability, and that at the moment is not being taken into account in any of these sort of precision farming approaches. So another one is archaeological impacts on yield. So these are 3 yield maps of the same field. It's the work field again with a Neolithic henge in, and you can see the blue is the higher yielding areas of the field, and you can see the henge coming out quite clearly. It's got a big deep ditch full of moisture and nutrients and organic matter, so of course it's going to have better yield. But also, again, thinking about archaeological practice and how it affects agriculture, these are where the locations of the excavations were, the University of Reading did. And of course that's damaged yield because they've dug up the soil, put it back, it's sort of jumbled up together. It's meant that there's actually not as good a crop there in that year. So again, pros and cons of both. And I guess the resolution of data doesn't help, again, archaeology, because you can just about tell the henge, but realistically you're not going to learn any more about the archaeological sites and the features because of that resolution issue. So carrying on with the nutrient angle as well, it's not just the big macronutrients, but also micronutrients that can be affected. Same field, same Roman villa, different sort of field patterns there. And this is the copper variation across the field. And copper variation can also mean that you get symptoms in the crop of poor sort of formation. So you get these curling tips on wheat plants when they've got copper deficiency. That was seen on one case study site, not actually this case study site, but again, it depends on the soil types, depends on what amounts of nutrients are in there, and depends on the levels of archaeological enhancement of those elements. This is turning the nutrient issue on its head. Sometimes having more nutrients is good and can help plants to grow. On the flip side, it can be bad. You can have too many nutrients and too much. So this is the lead variation on that same field, and you can see it's really quite high. There's clearly been some other types of fertilisers or some past land management practice that has caused a lot of impact of lead on that top corner and the bottom corner. And in fact, those pieces of the lead variation are near to plant toxic levels, about 10 parts per million off of being at the maximum limit that we would really accept in soils from guidelines. And then there's another zoomed in picture of that area where there's a World War I isolation hospital on some mapping that we had, and there seems to be a bit of a leading path of lead variation from the sampling going to that area, which is really interesting. Again, just thinking about it can be these sort of very short periods of time where a different activity was happening in that soil to affect the geochemical variability of that soil. And I'm assuming from what I can think of that could have caused that possibly is leaded fuel and vehicles driving along that trackway, or what that trackway was actually made out of, which has then left a residue of lead perhaps in the topsoil. But again, it can be from 2,000 years ago or it can be more recent. Another result really from looking at the variability caused by archaeology is how people sample soils. A lot of people tend to follow standard guidance on sampling soils, which might be one sample for the whole field, or if you're doing precision farming sort of methods, it might be 3 or 4 samples, but generally you would walk across and just take a rough average of that whole field. But of course, if you take one average of that field, you're going to get a very different answer to if you sample in certain places. So the exact location of where you're sampling is going to massively sort of skew your results from a farming angle. And again, no one in any guidance says anything about looking at archaeological sites to then inform your soil sampling. So there's room for improvement there by using archaeological data and information. The other thing, again on the same site, because this field had a lot of stuff going on in it, you can actually have an impact on soil health. So soil health has declined mainly because of loss of organic matter because of intensive cultivation. So to counter that, farmers are moving away from traditional fertilisers, which have been sort of part of the cause as well of that decline, and getting into using compost, manures, recycled sewage sludge from human treatment plants as well, coming out of cities. Again, it's trying to recycle nutrients in society, which is a good thing. So farmers are being encouraged to do this. However, some of these organic materials also have quite high levels of lead, copper, zinc, all the things that, as I said here, if you applied the same amount of that across the whole field, you're probably going to put that corner of the field way over its maximum levels of lead, for example. And so we can, again, have sort of some implication there for how farmers choose fertilisers and what fertilisers they put and what amounts they put on which areas. And again, because of archaeology. Agricultural trials is another situation. So this farm also ran trials on his sites to test out different types of crops, different inputs, and sort of, trying to make things more efficient. And this happens on quite a lot of farms across the UK, and the results of those would go on to inform guidance for the whole of the country through those companies. They generally say that trials should be put onto generally consistent areas of soil, because if you've got a trial that's running across different soil types, you're going to have different results that you've got to then account for in your results. But clearly this has not been thought of, again, relating to archaeology. These archaeological trial sites are cutting across multiple old historic field boundaries. There's just the example of one element of lead, but of course you're going to see variation on that level massively, and no one's taking account of that within their results. Another little part of my work was to think about how extensive these sorts of issues might be and what of impact, because a lot of farmers would say, well, archaeological sites are only small, they're only in that sort of corner of the field, they're not going to have that much of an impact on what I do as a farmer over the rest of the farm. So I did a few tests where I just took the archaeological records that we have, which are all the yellow parts from collations of that sort of data, for 1 kilometre square blocks, and then mapped it onto fields that are already there in those 1 kilometre square blocks. And it turns out that across 5 sites that I did like this, it was about 70% of fields have some sort of archaeological feature in them. So it's trying to, again, really make that point relevant to farmers and saying, well, actually there could be a lot of different types of archaeological features, or a mix of different types, that could be impacting your farming operation. And this is not one of my case study sites, but it's a fantastic image to sort of demonstrate, again, this idea that this was a trial site in Rothamsted Research Station, so it's in Hertfordshire in the UK. It's the world's longest agricultural trial. This has informed so many different agricultural tests on, again, plants, varieties, fertiliser tests, soil management, all sorts of things. And guess what's in the middle of it? A Roman mausoleum is cutting straight across part of that field, and who knows what else is under there, because they've been testing it on trials. No one's ever really been allowed to actually study if there's any further archaeological sites or boundaries or changes in land use on that site. So that's just another stark difference between this sort of archaeological impact on agriculture and agricultural methods. Another aspect which is slightly less relevant, but it's about the more large-scale data sets. Farms obviously are bigger. If they're collecting satellite imagery across a whole farm, suddenly that's quite a lot of data. They're doing nutrient tests quite regularly every 4 or 5 years across, again, the whole farm. So could archaeologists use some of these sorts of pieces of evidence, again, if they know more about them? If it's a phosphate survey, could we look for hotspots of phosphorus that give you an indication of previous habitation? It's almost going back to, well, geochemical prospection methods that have been used about 80, 100 years ago. But it just can help give an indication if there's no other data. So it's sort of just trying to use data that we have available, rather than necessarily having to think about going and doing everything ourselves. And then the temporal aspect of data, as I said, it's a life cycle of data collection going throughout year on year, multiple times, satellite images, lots and lots and lots of them. This is something just to draw up the sort of, and sort of show that through my 3 case study sites, where the red dots, red arrows are archaeological sort of pieces of data that have been collected. And then all the blue is precision farming ones. And you can just start to sort of get a sense, I guess, of, because everyone's starting to use more technology, both from an archaeological angle and an agricultural angle, the amount of data that we have relevant to some of these fields and these landscapes is just going to increase and increase and increase. And we need to find ways perhaps to use those, to understand those, and make sure that we're making the best, I guess, out of those sort of opportunities. So there's some of the main real conclusions of the research over those 3 case study sites and over about 3 to 4 years. And I think one of the most important things that I thought of at the start, I assumed that it would be the agricultural data that would be very useful for archaeologists to help find more archaeology, to help understand archaeology better, because we're always scavenging for more information generally. But actually, towards the end of it, I think it's the other way around. I think archaeology has got a lot more impact back towards agricultural methods and farming methods, and a lot more relevance in that sense, because of that resolution problem of some of the data sets, which is interesting. I didn't expect that. But one of the key things really is sharing data and actually trying to understand, or being aware perhaps, of all of these different things that are going on in the farming world, and for them the same on the archaeological angle, and trying to understand what archaeologists are trying to do. Ultimately, both sides of that coin are just trying to look at variability of soils and then interpreting something from that. They're looking at a soil field and saying, well, is there archaeology there? Is there not? Again, it's variation of soils, and the same from an agricultural point of view. So there's just that image again of the sort of Agri-Tech drive at the moment to sort of come up with solutions to agricultural problems. And I think one of the most important things really is recognising those soil and society and crop things, not just from today, what we think of as the sort of current challenges, but we can also look back into the past about those sorts of things, using archaeology as a way to explain why our landscapes have come to be what they are, and the variability and the diversity within those landscapes, which is really important. And the other thing is that archaeologists are quite well suited to this sort of thing, because archaeology is inherently a multidisciplinary subject. We're borrowing methods from all sorts of places, technologies from all sorts of places, to then focus on key questions. And I think that's sort of encapsulated in that image, and shows that we've got sort of quite a lot to be able to give to those agricultural challenges as well. So this is the final slide, just to sort of really sum up the global Agri-Tech movement will keep happening. These sorts of developments in technology will keep being used and tested out. And I think it's our sort of role to try and harness any opportunities that all of this data may give us in finding new archaeology, in managing archaeological sites. And hopefully my PhD thesis sets some of this out and really tries to start that topic and say, we need to look at more of these sorts of things, harness those opportunities, and be more aware of what's going on in other sort of dialogues, really. So that was everything. I don't know how I'm doing on time. But yeah, be all impression. So, are there any questions? I suppose?
I'm interested in soils, and do I understand right that there are no natural soils at all, because human being, which has influence all the time, and you mentioned that there's old soil and new soil, but they all are influenced by...
Oh, of course, yeah. No, absolutely. I mean, everything, whether it's direct impact or indirect impacts, humans have impacted those physical, chemical and biological processes, I guess, that have, made...
What does it mean, this old soil?
Oh, I see. So I'm talking about the sort of the formation of those soils geologically as well. So some of those more recently developed soils coming out of glaciation, for example, have obviously been impacted by humans, but they've had less weathering from a geological time point of view, rather than specifically an archaeological point of view.
10,000 years,
yeah.
Something like that.
Yeah.
Other question? Antti.
In the beginning you were talking a little bit about these stereotypes that are affecting your research. Have you encountered with some kind of skepticism concerning your motives from the agricultural community? And do you think this research might sort of pave way towards a friendlier or more collaborative relationship between archaeologists and farmers?
I think so, yeah. I mean, in terms of encountering skepticism, I sort of have seen lots of situations where farmers would react badly to what archaeologists want to do, because, if it's digging up their soil, it's sort of influencing and impacting on their operations, and they don't want to deal with it. But I think this approach, by trying to communicate what archaeology is to farmers a bit better, and actually by using this technological sort of the use of technology across both, we can hopefully explain and make it clear that archaeology can be good as well as bad, essentially, to farmers. I mean, it's not necessarily a positive and negative, but by understanding where it is, it might help you in your daily agricultural sort of systems. So I do hope that, yes, there will be further sort of collaboration, and I'm looking at projects sort of post-PhD to try and drive that forwards a little bit more as well, and actually taking this to more and more farmers, maybe running workshops or something to actually talk to farmers about it, rather than it being quite sort of high level and. But of course, there's a lot of variation. A lot of farmers will be very interested in archaeology because it is their, if it's their land, they're managing it every year. I think they'd be very interested. So. You get the full spectrum, I guess, which is...
Part of the challenge might be that you are working in academic cycles and how to communicate your results to the farmers.
Yeah, exactly.
Very different. So
Yeah. But I hope that trying to match it with sort of soil management and crop growth and that sort of the agronomy, I guess, of what farmers do, I think that ties it quite nicely together and gives a nice way of explaining it. So.
Yes, I have two questions about precision farming. When you're talking about precision farming, what is the extent? Like how many farmers are using these technologies? That's my first question. And the second question is, because you talked about carrying capacity and how many people you can feed and so on at the beginning. I mean, we're talking about what sort of improvements in terms of yields and are there any statistics on this?
So first question in terms of extent, there's been surveys, especially in England and the UK, that the government have run, and we're talking about 30-40% of farms or farm holdings are using precision techniques. But that doesn't mean that it's 30 to 40% of the land area, because a lot of smaller farms would not be using some of these newer technologies. It tends to be the bigger arable farms that would be using them. So actually in terms of land cover, it's probably more than that. And those figures are also about 5 years old, which is problematic because technology moves very fast. Actually, the industry has only really grown a lot in this area in the last 5 to 10 years, I guess, and overall. And different types of precision farming also vary. So GPS is probably the most common one. Most new tractors will come with GPS fitted onto them to allow them to spread fertiliser more accurately and do things. So that's probably one of the most common. And then in terms of yield, there are some predictions about increase of yields, but to be quite honest, the main attraction of precision farming is to reduce costs. Because yields, as I say, there's a lot of other problems there in terms of yield, which is not to do with just how much fertiliser you put on. There's some, I guess, ways of, gathering information on if you improve your soils, you get a better yield, but it's not very well documented on that. It's more about reducing costs and also, I guess, indirectly sustainability from if you're using less fertiliser that's been imported from Morocco, that's been mined out of the ground type thing. So yeah, I hope that answers your question.
One question, I was quite surprised of the percentage that you said that you actually found in this area that you were looking at archaeological features within, 70% I guess you said. And I'm trying to think what that could be, in Finland, and I think that we would end up with much less of a percentage depending on the
area,
soils area and stuff. Have you had any possibility to look at, let's say, different parts of Finland?
So the 5 1 kilometre square blocks were randomly chosen, with one on where my case study site was. So of course that is probably quite a high area anyway. Of course it would differ a lot if you then took an area in the Highlands of Scotland or something, and those sorts of things. But of course, in terms of again linking to agriculture, a lot of that damage from a heritage perspective is happening on those agricultural areas, not necessarily in the areas where we're not farming. So in some senses, actually you get that archaeological density where humans have also lived and been active in very dense areas. So, but yeah, I can imagine it will vary, of course, across lots of societies. So
I think the overall population densities in Finland were much lower in the past than they were here in Britain.
Yeah.
And also, one key element I think is also that, yes, Britain was part of the Roman Empire when we had big agricultural units, and Finland unfortunately was outside of it.
I'm sorry,
unfortunately.
Really interesting results, I have to say. Having grown up in a farm, this is all really interesting also from my perspective. I know I have a number of old friends who are sort of going into precision agriculture.
Okay.
I think it's more with GPS. But with them also, you have difficult fields, just knowing how deep to cultivate and plow, and it differs, if you have slope or whatever. So that's all something that they used to know in their heads, when to do what. But
exactly. Because like my dad would say, well, I vary my fertiliser spreading because I just slow down or speed up with my tractor. Exactly. But of course, it's all just a manual thinking about things, whereas the technological input means that you don't have to think about it. Anyone can be doing it, and you can do the same thing every time. And so it takes an element of human error out of it, whether that's good or bad. But
Antti, you have another.
One more question. Maybe you mentioned it, but we were talking about multispectral photography and farmers are using it. How available is the data? Do you have to? Can you access it, or are the farmers sort of jealous of it? Or?
Yeah. So the data that is the next sort of bigger challenge. Really, is as I said, the important thing is about being able to share that data, and of course a lot of it is all private commercial data, but one thing that I think could be quite simple to do is if you're working with a farmer on a site, you can ask that farmer and he can share that data, but you couldn't then go to a company that flies drone surveys regularly and say, I want to access all of your data, because they're not going to do that. So there needs to be a bit of a mutual dialogue, and perhaps there are ways of, this is why I was sort of concentrating quite a lot on the implications that archaeology has for their services, because if you can show that there's something to be swapped there, you say, well, we can provide archaeological data on things that will help you, but if in return you share agricultural data as well. But in terms of a very practical site-based thing, the best thing is to ask the farmer, because they will know what they've had done and a whole mix of things. So and they're usually very happy to share it on that sort of scale.
Bianca, you have another question.
Yeah, Henry, thank you. Brilliant. Now I finally understand what you're doing. You have been talking so much about it, but I was still confused. But my question is, how do you see the future for this? Because in order to exist a collaboration, maybe even some institutions, some laws regarding this kind of collaboration, you need specialists. From what I understand, you're kind of like the only specialist now, being archaeologist and farmer at the same time.
Yeah.
So in practical ways, how do you think this sort of ideas could be advertised and could be more popular and have people actually knowing what they are talking about?
Yeah, other than me having to go around and talk to every single person. Yeah. So, I mean, partly, I guess, is for me to then push that towards the people, the agencies, like the heritage agencies, like Historic England, where they were partners in the research, and they're very interested to then include this sort of stuff in their guidance, or if they're aware of these sorts of things, they can then use that to help talk to other people. And again, it's, I guess, making those connections, because actually if you got Historic England then working with these precision farming companies that are doing the data sort of side of things, I could see there being quite a lot of future collaboration there. But it does need people to positively take that forwards and interested. But a lot of, so there's already been some sessions organised at like a landscape archaeology conference, and there's people starting to work on these ideas further from like a data sharing point of view, as well as a data collection side of things. So hopefully maybe this is just the start and that people will follow along, and if it's interesting, if it's useful, then yeah. So.
Okay, I've got a set of questions from... Sorry, to speak with the microphone. I've got a set of questions via email from Martin supervisor.
Yeah.
Martin wrote, are there many congratulations on an excellent lecture which I was able to pick up on YouTube? The questions I could think of, by the way, of why about grab where. First, you made use of existing data sets. If you are planning a monitoring program from the outset, what techniques would you particularly foreground? Can I repeat or?
No, I can not yet. So out of those techniques, it would depend on what sort of archaeological sites you're looking at and what sort of soils you're looking at, but certainly soil nutrient variability is key, because that is the real direct link into what farmers need to know about. So that's probably number one in terms of the soil sampling and the topsoil mapping. Two would be geophysics, because that gives you a nice clear image of where archaeological features are across that field. And it's not just saying there's a Roman villa here, but you can say there's all these field boundaries, there's all these sort of different bits and bobs. And then satellite imagery, which is again one of the sort of more temporal aspects. You get lots and lots of updates. So if you combine those three, that would be probably one of the best in terms of a monitoring project, I guess.
And the second question by Martin, to what extent were you able to take account of down profile variation in your soils?
So with doing the coring transects, that enabled a better idea of where the variability was, because of course topsoil variability could just be a reflector of subsoil variability and not necessarily be archaeological in its sort of nature. So by doing that, it was very useful as a sort of a check almost on where the variations in geochemistry or whatever were being. So yeah, they were quite important, although probably less important from a monitoring and mapping point of view, because it's very spatial really in nature. It's all about spatial variability and not necessarily so much about verticals.
And a third question by Martin. How did the variation of soil horizon sequences in the field enhance your work?
How did
the variation of soil horizon sequences in the field enhance your work?
Oh, enhance work. So they actually made it far more complicated, really, because, again, one of the pictures that we're getting from mapping these fields in lots more detail is that soil variations, both laterally and vertically, were much more complicated than what people thought before, which makes it more problematic from an identifying archaeology point of view, because, again, it's all about this sort of what you're looking at versus the background of what you're looking at and trying to find that. So that made it more difficult in some respects. So some sites, like the Iron Age enclosure, had higher levels of phosphorus in the enclosure, but you couldn't really see that from the topsoil map because there was also high levels of phosphorus caused by chalkier soils that were containing phosphorus sort of, bound up into the chalk elements. So yeah, slightly more tricky actually, but yeah.
And then his final question. What do you think caused the high lead at Minson Farm?
At Purderswell, yeah. Yeah, no, there wasn't much high lead there. That was...
Okay.
But it was probably at Purderswell was where the lead map was. Possibly two different sources. Again, the lead towards the isolation hospital, I think, was probably leaded fuel or something within the trackway. But to the left of that, there was a whole field boundary that was covered in high lead. So that is probably from a different type of fertiliser, perhaps like a slag of some sort that contained high lead, because farmers do often put metalworking slags on as because, again, they're sources of nutrients, but they can also contain a lot of heavy metals. So I suspect it was something to do with that, but obviously wasn't applied to the rest of the field.
Thanks, Martin.
Thanks, Martin.
Any other questions from here? Yes.
You were exploring and comparing, let's say, or overlaying archaeology and agriculture more from agricultural perspective, and how that can, just knowing these sites, how does that benefit the agriculture?
Yep.
But then, if we see from another perspective how agriculture is affecting those sites, have you?
So one thing I was trying to do, which I think has actually been sort of left a little bit from the PhD, is really looking at that heritage angle and saying, well, actually, could we implement a different technology there to then help conserve that site and actually evidence that? Because I've only gone through really the theory of that. And that was something that was probably pushed into what will happen after the PhD. So I did tend to focus on the data collection side and making that point first. But I think that also ties you into different realms of policy and environmental schemes and that sort of thing, which I think I just didn't have room in the thesis anyway to go into. But that's certainly something that I was originally intending to try and look at, and maybe will be future ideas for the next project, really.
Any other questions? If not, thank you very much, Henry.
Cool, great.
I think you have made
Thank you for listening.
case here for agriculture and archaeology. And I think we may go to the thirsty scholar, or some of us might go now. And for the rest, thanks again to Fiedler for co-organizing it. In 2 weeks, I think in 2 weeks or 3 weeks, there will be the